Welcome to the SimuGator LSAT lesson for the June 2007 Logic Games, questions 11 through 17, or Game 3. For more free information about preparing for the LSAT and applying to law school, visit simugator.com/blog. We won't actually reproduce the actual test questions in this lesson. However, you can download them for free at this following address. So read the problem to yourself now. This is how I would summarize the rules. We have 4 destinations, G, J, M, and T, our variables, for 7 weeks. Each destination is traveled to at least once. Week 4 cannot be J. Week 7 must be T. M must be used exactly twice, and furthermore, there must be one G variable in between those 2 M's. Whenever there's a J, G must directly precede that J. Lastly, there cannot be any consecutive variables, so you can't have 2 M's or 2 T's in a row, for example. So we're going to start our diagram by simply making 7 slots. We will plug in the T variable into slot 7 because we know it must go there. Now underneath the diagram we have variables. These are called negative deductions where things can't go. So under slot 4, put a J, because we know that J can't go in that slot. The rule against consecutive variables means that T cannot go into slot 6, so put T below slot 6. And the GJ rule means that J cannot go into slot 1, because there's no room for the G to go in front of it. So that's our diagram, and that's really as much we can do right now. So let's go into the questions. Question 11. As with the first question of most logic game sections, this question is very easy to solve. The approach is simple. We go through the answer choices, comparing them to the diagram and the rules, and we look for violations. So we know that J cannot go into slot 1 or slot 4. This eliminates answer choices C and D. We know that T must go into slot 7. This eliminates answer choice E. We know that there must be at least one G between the 2 M variables. This eliminates B. Thus, answer choice A is the correct answer. Question 12 asks what cannot be true. We will use our master diagram to easily solve this problem. So attack this question by going through each answer choice. Answer choice A has T in slot 6. Take a look at the master diagram and our deductions. We know that T can never go into slot 6 because of the rule that forbids consecutive variables. So this is a deduction that we made up front when we did our diagramming, and it's going to get us the correct answer very quickly. So because T can never go into slot 6, A is the correct answer. So this truly demonstrates the importance of negative diagramming. Focusing on where things can't go as much as where they can go will save you a lot of time and will get you the correct answer in many questions. Question 13 asks us what could be true when T is in slot 5. So let's make a mini diagram that has T in slot 5, and then let's add our deductions. So we're going to put T in slot 5 there. The rule forbidding consecutive variables tells us that T cannot go in slot 4. The rule telling us that G must come directly before J tells us that J cannot go in slot 6 because T's presence in slot 5 would block the G variable. So now we want to make one possible solution, or more than that, that comply with the rules. This will be very easy because the GJ rule and the MGM rule are severely limiting. So if you focus on the rules that are very limiting, they will often lead you to the right answer. So look at the diagram. There are only 2 possible locations where the GJ block can go. So J can go in slot 2 or J can go in slot 3. And this is what it looks like. So we effectively have 2 mini diagrams here, one on top of the other. So let's fill in the rest of the possibilities, complying with the rules. So on the bottom diagram, M must go in slot 3, G must go in slot 4, and M must go in. let's do the top. And that's how it looks like. In slot 4 and 6, the slash means that it could be either or. So we have our diagrams complete now. With all the possibilities diagrammed out, let's go to the answer choices and eliminate everything that does not comply with the diagram. So just go down the list. Answer choice D is the correct answer. Question 14 gives us two new conditions. G is in slot 1 and J is in slot 5. So let's make a mini diagram depicting this. And that's how it looks. Let's make additional deductions based on our rules. Okay, there we go. So we know that G must come before J. The rule prohibiting consecutive variables means that G cannot go in slot 2 or 3. And if G can't go in slot 2, then we can't have J in slot 3. Furthermore, J cannot go in slot 6 because there's no room for the G variable in slot 5. So those are all the deductions we can make right now. So let's complete the diagram by putting in additional variables that comply with the rules. From the looks of it, we still need exactly 2 m variables. Because we can't have consecutive m variables, it seems that one must go in slot 6. But let's diagram it out to see how it looks. Alright, so in slot 2 and 3, we can either have m or t. But slot 6 must have the variable m. Don't get confused with answer choice B that says that t can go in slot 2, because this is a must-be-true question. It's not a could-be-true. Slot 6 must contain m. Accordingly, answer choice E is the correct answer. Question 15 gives us two new conditions. It says that G is in slot 1 and T is in slot 2. Let's take the same approach and make a mini diagram. So we have G and T right there. The rule against consecutive variables means that T cannot go in slot 3. And further deductions, J cannot go into slot 3. And that's all we can do. Now, it seems that J can only go in either slots 5 or 6. This is clearly shown in our diagram with the negative deductions. Now, if J went in slot 6, then G would have to be in slot 5, forcing the two m's to be next to each other in slot 3 and 4. This is a violation of the rule that prohibits consecutive variables. Accordingly, we must put J in slot 5. Let's complete the diagram to see how it looks. And that's how it looks. With the diagram complete, let's go to the rules and eliminate all answer choices that could be false, which is the converse of must be true. This will be very easy because the diagram below represents the only solution for this problem. The only answer choice that works is A, which is the correct answer. Question 16 asks for a list of variables that could go in slot 4 and 5 when the variable m is in slot 3. Now, a quick glance at our mini diagrams from previous questions reveal that we have already made a diagram where m is in slot 3. Specifically, take a look at the previous work from question 13. Let's see if it can help us solve the problem. Okay, so here's the work from question 13. The bottom diagram specifically has m in slot 3. This solution reveals that when m is in slot 3, slot 4 can be G and slot 5 can be T. Now take a look at the answer choices to see if you can benefit from this information. Indeed, answer choice A has G and T in slots 4 and 5 respectively. Thus, A is the correct answer. This question demonstrates the importance of quickly glancing at your previous work to see if it can benefit you. After all, why reinvent the wheel or do unnecessary work? If you didn't realize that your previous work could quickly solve this problem in under 20 seconds, then your approach would have been to make a mini diagram, plugging m into slot 3, then making deductions. Negative deductions would reveal that neither J nor M could go into slot 4, thus eliminating answer choices B and C. You would then test each of the remaining answer choices, A, D, and E, by plugging their variables into the diagram to see if they can comply with the rules. But I prefer a quick glance at our previous work to save us all of this trouble. Question 17 asks us what must be true of all our solutions. This means that all the wrong answers could be false. We should attack this question by using our previous work. Because the right answer must be true in all solutions, we can compare our previous work to the answer choices to eliminate several of them. So let's go down each answer choice to see if we can eliminate it through our previous work. The answer from question 11 actually eliminates A, because it shows that G does not have to be limited to slots 1 and 2. It can also go in slot 5. The answer from question 11 also eliminates answer choice B, because it shows that M is not limited to slots 2 or 3. It shows that it can also go in slot 6. So now let's look at the remaining answer choices, C, D, and E. They were all very similar, and they state that the variables G, J, and T can occur at most 2 times. This means that 2 of these variables can occur 3 times, while only 1 of these variables can occur 2 times. So how do we figure out which variable can only occur 2 times? Our previous work does not help us here. Now we could make mini diagrams, guessing and checking, to see what variable can only occur 2 times. Or we could think about things analytically and mathematically, and we could work smarter and not harder and get the correct answer very quickly. This is what logic games is all about. We know that whenever there is a J variable, there must be a GJ combination. So mathematically, every time we have one J, we actually have 2 variables, G and J. So that's 2 times. This is a huge restriction because we only have 4 available slots. If you recall, T must occupy slot 7, and we must have exactly 2 M variables. So 7 slots minus 3 ones that are already taken means that we only have 4 available slots. Mathematically, we can have 2 J variables because we have room for them. Each J brings a G, so 2 J variables would make 4 variables total, which we have room for. However, we can never have 3 J variables because that would require 6 open slots. We only have 4. Thus, it can be said that we can only ever, at most, have 2 J variables. Answer choice D is thus correct. So we hope this tutorial served as a thorough explanation to this particular logic game, but hopefully it gave you great visual insight in how to approach every logic game. So when you make your master diagram, focus on where things can't go as much as where they can go. This is a huge skill to learn on logic games, and it's going to lead to great breakthroughs and inferences that you might otherwise miss. Use the master diagram to solve the problem, and if you can't, make a mini diagram based on the master diagram specific to that question to see how things will play out. Don't erase your previous work, because you could always glance at it and maybe benefit from it. Some students do not appreciate the helpfulness of this tip because they feel like they're cheating or they're not really learning the LSAT. But this is not a coincidence. Where your previous work will help you is specifically contemplated by the LSAT makers. You have to remember that your previous work is just one solution for the problem at hand. It won't always help you, but it could help you. So why not quickly glance at it and see if it does help you? And why redo diagrams if you already have a solution that works in front of you? So we hope you enjoyed this lesson. Check our blog, subscribe to our channel, and visit our channel next week for more lessons. Thank you and good luck with your LSAT studying.